Create draft as a feature. In this video, we'll use draft on a body and use split face. In Fusion 360, we want to carry on with our drafted spur gear. At this point, we've modified the original extrude features to include a draft or taper angle. We know that the side faces of the gears or the teeth themselves are drafted minus half a degree. When we take a look at the rest of the design, we have to be mindful of its intent. In this case, we need to preserve the round shafts as they're going to be used inside of a bearing surface. So keeping that in mind, we can't simply add draft and taper it toward the Z direction, because that means that the bearing that gets pressed on here is likely only going to have a single point of contact. So in this case, we're actually going to be drafting it in the Y direction. The first thing that we want to do is go to Modify and select Split Face. When we look at split, we have three different options, and in this case, we're simply going to divide the faces of the areas that we want to draft, and we don't want to divide the body itself. By using split face, we need to pick the faces that we want to split, and in this case, I'm going to select all of the different faces that are included in the areas that we're concerned about. So this will be all the way up to the top, and once I'm happy with those, I'm also going to select the top face of the gear, and then I need to select my splitting tool. For me, that's going to be the XZ plane. So I'm going to go in and select XZ and say OK. This is still a single solid body, but now we've divided it up so we have better selection for applying that draft. We're going to go to Modify and select the Draft tool, and then we can begin by first determining what type, a fixed plane or a parting line. Now, the parting line option is great in certain instances, but for our case, we don't want to use parting line because we're going to be focusing on one side of the split and then the other. In some cases, if you want to include that split or the parting line, you can use a sketch to help determine where the part is going to be split and then draft on either side of it. It's a little bit more of an advanced technique, so we're going to focus our attention on using the fixed plane method. The pull direction is going to be our XZ plane. So I'm going to hold down the left mouse button and select XZ. Notice that it's showing an arrow for the pull direction, and if we need to, we can flip. I am going to turn off tangent chain because we still have tangency even though we split the faces, so we want to make sure that we deselect that as an option. Now we can go around and select all the faces that we want to draft. When we do this, notice that it lets me select the first face, but it's not allowing me to select the side face here. It's only allowing me to select these top faces. For the angle, let's enter G and use gear draft and see how this affects the model. Sometimes it might be hard to tell, so we can artificially use a larger value to ensure that we are actually drafting in the direction we want. When we add 10 degrees, we can see that we are adding quite a bit of draft, so we can go back and use gear draft, which is half a degree, and we're going to have it draft on one side. We'll say OK. And now we've applied that draft. If we look at it from the right-hand side, notice that it's actually drafting up to that line and moving away at half a degree. We're going to repeat the process using our right-click marking menu. This time the pull direction will be the same. So I'm going to select that XZ plane. And for the faces, we're going to use the faces on the other side of our selection. If you need to, you might want to hold down the Control or Command key to make sure that you are selecting all the faces. It remembers our half degree selection, but we want to use that gear draft parameter in case we need to make any changes later. We'll say OK and take a look at this from the right side. While it doesn't necessarily appear like we have enough draft, let's verify this by using Inspect and creating another draft analysis. We'll use the same body selection, but for our plane, we need to use XZ. We're going to take a look at it from 0.4, positive 0.45, and negative 0.45. Remember, we are using half a degree, and we're going to not use anything in the tolerance zone. If we have any difficulty setting these values, you can always reset them to 0, and then you can use the slider, or you can use the up-down arrows to get us closer. Once again, I'm going to alter these to 0.45, so I have complete colorization. If I were to reverse the direction, or take a look at some areas of concern, you can see that right in the middle there's a small red area. Now, oftentimes when we apply draft to a model, what we're really doing is we're giving it a way to self-eject from a mold. As the plastic cools and begins to expand, we want it to automatically eject itself from the mold rather than get sucked into the mold and not be removable. When we're talking about a shaft where we have a rounded section coming directly up to the parting line, the majority of that shaft has plenty of draft on it. But right at the middle or right at the parting line, oftentimes you will have a slight problem. You can get around this in most cases by talking to the manufacturer and seeing if they can actually draft or use a part that's undrafted around the round section. If they need a draft, we can always put a small flat section there and still have the functionality needed to actually support the bearing. In our case, everything looks pretty good, so I'm going to say okay, and just verify that I have applied the draft to all the areas. We go to our analysis folder and take a look at the first draft. You can see that we still have areas of concern underneath. So we can use modify, draft, select the type, the pull direction, and the faces. In our case, the pull direction is going to be Z. So the plane that we're going to select is XY. The faces that we want to draft are going to be any of these side faces. And it looks like there is a small amount of green and red that's displaying on the side here. So let's make sure that we select that small face as well. And then the draft that we're going to want to use is that gear draft value, and we'll say OK. If those are showing up green now instead of red, that means that we have enough draft. So everything looks to be OK. You can always validate this by going to a bottom view and seeing if you can actually see that face. Well, right now we can't see that face, which means that the draft is actually in the wrong direction. If we modify this and we flip the pull direction and we say OK, now we can see those faces. If we turn on the draft analysis and we rotate this around, the faces are now blue instead of green. So even though at first they appeared to be okay because of that green color, it is important that we do verify that before we simply send the model off. Let's minimize all the folders and go back to a home view. And at this point, let's make sure that we save the design before moving on.